Hello, everyone. Welcome to the webinar where we'll be talking about building scalable data products. This presentation includes our customer resilience and our partner AWS. My name is Vishal Singh. I am the head of data products, lead the team on data governance and the Python ecosystem. Anthony, would you like to introduce yourself?
Hey, thanks, Rochelle. Hey, everyone. Hey, Adam. I'm Anthony Prasad Devraj, Senior Partner Solutions Architect at AWS. Been working with partners like Starburst to build product integrations and work on go-to-market strategy as we speak. So looking forward to presenting today to everyone and get started with this webinar.
Adam?
Yeah, hi everyone. I'm Adam Mendez. I'm head of data engineering and architecture at Resilience, which is a biomanufacturing innovation partner based in San Diego. We are longstanding customers of Starburst and even longer standing customers of AWS, and looking forward to showing you what we've been able to build today in collaboration with each of them to really accelerate our analytics capabilities.
Awesome. Thank you, Adam and Anthony. Really appreciate you joining the webinar and talking about the complete ecosystem with Starburst AWS and Resilience. Before we go more into what we are doing, what we're building, let me actually explain how the Starburst is built with our partner AWS. We are built completely on the AWS ecosystem. Also, we actually work across the hybrid and the cross-cloud environment. We have the different layers in our system. One is the layer of the query engine, which is completely built on the top of our open source Trino, which contains cost-based optimizer, cluster auto scaling, Trino dynamic filtering, and query federation. The Trino runs at the petabyte scale. We have also built around Trino, which includes things like security and governance, which we have RBAC and ABAC with the lineage and data quality built into it. And the data access where we can deploy at any places across on-prem, on AWS, or any hybrid environment, and create the modeling and semantic layer like data products, materialized views, catalog, global search, and data profiling metastore. Any analytics created from Starburst can also be consumed into different third-party integration like QuickSight. You can also use AWS Glue and use information like lake formation and other with the Starburst environment itself. But today we are talking about data products. So what are data products? Anthony, what do you think are data products?
I think first of all, let's understand, right? Let's understand how do we define a data product, right? So a data product can be any application that you offer to your customer that actually helps them solve a business problem, right? With the use of data. Like any other type of product, a data product needs to be usable, viable, and feasible, right? So when you talk about usability, we're referring to the fact that the data product actually helps the customer solve a real business problem, right? And also, it has to fit into their established business processes, right? So we don't want to deviate too much from the norm, right? We want to reuse as much as possible, right? And then viability would refer to if this particular data product actually makes financial sense. Is it worth the investment, right? Or does it have a commercial potential, right? So some of the questions, the customers got to ask themselves is, can it draw revenue, right, directly from this outcome, right? Is it going to improve the value proposition of your product offering, right? Is it going to attract investment, right? So these are kind of questions that the customers should ask. And then the last but not the least is feasibility, right? So when we talk about feasibility, we're talking about the technical aspects, right? You want to make sure that your technology is the appropriate technology that is used to solve your problem, right? And not only that, but your team has the expertise to use this technology to solve the business solution, right? So it's kind of the whole triage, right, of all three lanes.
Absolutely agree. In fact, if you double click into it and then look into what exactly the different attributes of data products are, exactly what Anthony you mentioned, like it has to be a highly curated data set, which is meant and curated for the business use case. And you want the data products to be discoverable into a single place. What if the data products in different different region. I create data products into US East 1, which is North Virginia region, and what if my data products in the EU region? How can I actually empower all my folks in the organization to discover the data products coming from different business units, different regions? And how do I secure and govern at scale? For example, as the data team is producing new data products and as the new stream of data sets are coming, how do I use the business attributes and domain-based attributes to govern my data products at scale? And usability. It needs to be curated for both business, technical, and non-technical users, because there could be a source data product and there could be consumed data products. Source data products can be used to create consumed data products. So how do I expose data products where data engineers, data team can also use the data products to create a different data products, or data analysts or business analysts or data scientists can actually understand and take data products to create business insights for the organization. Data products are supposed to be used many times because there's no need to create a data product for ad hoc use cases. You are creating data products where it is intended to be used many times, and thus also learning the consumption pattern and best practices so that we can empower users in the organization into how to use data products, which leads to lower TCOs because the faster time to insight means lower development costs. If you're not recreating the data products again and again, then you have reduced storage copies, that's fewer copies. You have less maintenance of those pipelines. And maintenance of data is also goes down because instead of maintaining 10 or 20 different data sets, you are maintaining one data product which is being used and for curated for many business use cases in the organization. And in the end, these are the foundational elements where you can take a data product and create secondary and tertiary data products on top of that. Starburst Data Products is a data product platform for data organization that need to rapidly connect data consumers with high quality, reliable data sets. Where did we start? This is what I see, and Anthony will love your input here. I see that data products evolution happens because of the data producers and data consumers. Data producers wanted to expose the curated data set to data consumers, and data consumers knew there are curated data set, but they're spending time just to understand what the data is and how can I find the data sets. And that's where the discovery and prep is the main core components into where the evolution of data products becomes really important and needed in the organization. Anthony, what do you wanna?
Yeah, no, I completely agree, Vishal. I think if you look at it, data discovery and preparation, are often cited as the most time consuming, right? Step in, a typical data analytics, product life cycle, right? It's around 80% of the time or more, right? And I think the tribal knowledge along with decentralized sources, that's going to result in the ability of the customer to find and curate these data sets, right? So there's a lot more expertise involved, right? And I think data curation is a key step in defining your data product, right?
Agreed. I mean, like, how do I actually even data producers? They don't want our data consumers to just create the ad hoc data sets because they cannot find the data sets. So this is where the multiple copies of exactly same data sets get created in the organization because the data consumers are just not able to find where the original copy exists and where original business approved copy they should be using for the use cases they're driving.
Yep, exactly. Yep. So when you start to work on a new product, I think the first thing to figure out is are people actually willing to pay for it, right?
Correct.
So that's where the concept of the product market fit comes into place, right? To get there, you got to be quick, you got to be agile, you got to be cheap. So basically, what we say is at AWS is, hey, let's just create a minimal viable product or MVP and get it out there as soon as possible, right? Get it out of the door. And then what we do is we take feedback from customers, right? So we listen to our customers and say, hey, how do you think of it, right? What do you think of the product? We actually listen to what they say, and if they like it, we keep going, we keep iterating. If not, it's time to pivot and try something new, right? So at AWS, we've done that several times over. We create products, we get the feedback, and then if the customer doesn't like it, we scrap it, we redo it, right? Now, let's assume that, great news. The customer is happy, thinks the MVP is awesome, but could use a little more improvement, right? So that's the growth phase, right? The second phase is growth, right? And then I think this is extremely important because sometimes what happens is people just get out an awesome product out there and then they don't iterate over it, right? So that's you're behind in time, right? And then once you have the growth phase, right? So you establish a great job on getting your product to a good place. After a few months, you go GA, right? Now it's time to scale, right? So that's the third phase, where how do we scale things up and deploy this to multiple customers, right? So then we look at automations, we look at deployment models, right? How do we simplify the time to be deployed, right? At the end user's VPC, for example, right? So these are optimizations that we continue to work on, and that's how we build, a good data product.
Completely agree with you. Completely agree with you. And this is why, as we're doing through this product lifecycle, where do you want to take this data product? Because the data product is going through evolution, is now actually being exposed to the customer. But the next question becomes, how do we inspire confidence in data consumption by building trust? And this is where we have seen the other aspects where poor quality data impacts decision, cost, and trust. We have seen data producers and data consumers where data producers say, I need to deliver reliable data to my consumers. And data consumers, I know where the curated data sets are and the business context, and I need to verify the fitness. So sometimes even exposing the data product doesn't mean that the job is done, as Anthony you said, because you are taking the MVP, you're evolving and scaling it. Which brings to the next point. As a data producer, they're looking to maintain and build trust with stakeholders. They want to reestablish the trust if the data goes down. And how can they proactively maintain the trust around the data? And the data consumers have the different side of the coin and then asking the similar question. Is this data still good to use as it went to the new iteration? I have used this data set previously for the different use cases. I see new data coming in this data set. Can I still use it? What other use cases is it solving? And I have concerns about quality. How can I get this addressed? So as we are going to the product lifecycle, the discovery becomes into the trust issue. How do we continue to build the trust during the lifecycle management of data product? And how do I actually empower both data producers and consumers to understand and build trust with each other?
I think, just to touch upon what you said, Vishal, I think data quality is something that is often overlooked, right?
Absolutely.
And I think the poor data quality obviously leads to flawed decisions and there's inconsistencies, right? And it actually results in a ton of losses for organizations, right? For example, if you're an airline company, you are requesting for a spare part, right? Now, let's say you get an incorrect spare part being delivered. As it is, the procurement process is pretty tedious, right? It's going to take a ton of time to reship the product. And by then, your production line is impacted, right?
Yep.
So this is like millions of dollars of losses, right? So all this could have been avoided if we had the right guardrails and data quality checks, right?
Agreed. Absolutely agree. In the end, and then to the point, like the quality, the data as any software product, it goes down. And if it goes down, how do I actually go back to the original quality or the desired SLA, which was initially intended and communicated as a part of data product?
Exactly. Yep. And I think, I just want to touch upon the modern data architecture that we believe at AWS, right? And this diagram kind of shows the AWS vision and offering to enable your data product management, right, and development. And I just don't want to spend too much time, but I just want to go through it quickly, right? So in the center, you'll notice like your data lake is on S3, right, which is highly scalable. Around it, we got data warehouses and purpose-built databases, right? And at the same time, we have different data services to allow data processing, data movement, data integration, right, at different scales. And at the center, you have Starburst Galaxy, where you can actually leverage Starburst Galaxy to federate across all these multiple disparate data sources. So let's say your data is residing in a relational database, right? Or your data is in S3. You can actually leverage Starburst Galaxy and federate across those data sources and run your analytical queries, right? Now, this might sound a little too high level, but this is exactly how we build a data product use case. And then based on this, you can replicate this for your line of industry, whether it's media and entertainment, fintech, gaming, and whatnot.
Great, great. So how's Starburst special in this whole situation? We are built on top of AWS. We are leveraging all the ecosystem around AWS, which is S3, Lake Formation, and Glue to build and publish data products. Adam will be touching this upon more in details into how he has taken the ecosystem around Starburst and AWS and built the data product successfully in his organization and what problems he has solved. But overall, Starburst provide as a platform where you can discover, create, and publish, and manage and share all your data products, where you can have a streamlined visibility and consistent governance. You can actually have a data products have a very different visibility, both on the column level to row level, based on the user's persona and domain they're coming from. And ultimately, they're able to query data products that is trusted and a proof of frequent use cases, and rate and inform the data consumer into what they need to do to evolve the data products for the new use cases they're trying to solve and resolve.
Thank you, Vishal. No, I completely agree. I think like I was entailing in the previous diagram, I think Starburst has been extremely critical for our customers to run their cross data source analytical workloads, right? And I'm looking forward to seeing Adam and how they're leveraging it. But over here, I want to show some of the data product examples, right, that we've seen from our AWS customers. And I'm sure, you could resonate with one of these or all of them, right?
Great.
So the first category is, includes dashboards and reports, right? So these are standard dashboards and reporting that they consist of either derived or aggregated insights from raw data. Then this is able to actually guide end customers and help them take decisions, right, on the fly. The second category is, data APIs, right? And this is becoming increasingly popular. And it provides access to raw or derived data through a REST API, right, or a SQL interface. And these type of data products actually allow end customers to run their own analysis on the data, right, and build even more complex data structures, right? The third category, I like to call it like data collection and indexing. It's all about collecting data from the customers, index it for search, right? So we want to index it for fast search or generate actionable insights, right? And now it has a wide range of use cases, right? From real estate listing and searching, for example, vehicle telemetry and monitoring, or behavior analytics, right? From mobile and web applications, right? So the applications and use cases are limitless, right? And lastly, right, this is becoming, the conversation, a hot topic, as we go into this year, is machine learning, right? So machine learning models as a service can actually power customers to use intelligent product capabilities, right? That includes automated decision making or process improvement. So we're letting the machine take decisions on our behalf, right? So that is the way I see the evolution of data products.
Makes total sense. And even sometimes we have seen, for example, the dashboard and data APIs being consumed to single data products. How do I actually understand, like, I want to access this from the APIs, and where the dashboard, this data set and data products can be used? So how can I actually create the singular context to expose the right data set and right information to our customers?
Absolutely. Yep. So in this diagram, I know it seems very complex, but I think the essential takeaway is, I know we touched upon the modern data architecture, right? So if you look at your left-hand side, we are addressing multiple use cases, right? So we have data coming in from streams, right? Live data coming in through Amazon Kinesis data streams. We have data coming in from RDS, Aurora, other data sources, legacy data sources, right? And all of these are seamlessly federated, right? So you have AWS Glue that you can do, if you need to leverage some ETL, complex ETL operations, you can leverage Glue before dumping the data into S3, or you can actually run analytics as is by federating using Starburst Galaxy. And one of the important aspects you need to understand is I think we're moving to a world where we're trying to avoid the ETL process, or we call it zero ETL integration, right? So that is something that our customers are looking forward to. As a recovering data engineer, I can tell you that we spend hours, curating data sets, extracting, transforming, and loading that. But today, we have definitely simplified that process, right? So you can actually directly federate queries. You don't have to move the data. You can keep the data as is. Make a copy in Redshift, for example, for a reporting layer, surface that in something like QuickSight, right? I'm sure Adam will talk about how he's leveraging that in his use case as well. So we have a ton of options, and the advice that we give to customers is use this as a skeleton, right? This may not be the exact fit, but use this as a skeleton, and you can build your own application.
Give me 1 second. There's one more slide which is not loading, so apologies for that. Here, in the end, I do want to close before we hand it off to Adam to talk about AWS and Starburst. But again, Anthony, I mean, I've been very excited. One of the things when, as a product manager working on AWS, has been is all the ecosystem AWS provides with Starburst to actually provide those mechanisms in more prepackaged way with the technology built like on Trino. Like for things that are on the relational database, like having access to Redshift and combining the data from Redshift to S3, and also able to use the AI ML services like these services like a Bedrock, and also and using the Python workload within the Starburst ecosystem, and also like trying to connect all the data sets within the ecosystem, and also do cross-cloud queries, cross-region queries in the AWS. So I mean, as a product manager, it's really exciting to build on the top of AWS and also speed up our development and reduce the time to insight with the high-level services which we can build with Starburst.
Absolutely, Vishal. And I think, just to summarize and close it here before we hand it over to Adam, is I think it's important to understand wherever everyone is in their journey. I think when you want to start building a data product, hit the market early, gather feedback, and iterate fast as possible, right? Great. So you can achieve this by focusing on the MVP, reuse existing architecture. You don't have to build something from scratch because we already have them, available for you publicly, right? And then leverage some of the high-level AWS data services, right? As you can see, as we've talked about, right? So with that, I think we can hand it over to Adam.
Awesome.
Thank you.
Thank you.
Okay, perfect. Let me take over the screen share then. You probably see nothing there. And can you see that now?
Yes.
Okay, perfect. So like I said at the start, I'm Adam Mendez. I'm head of data engineering at Resilience, and very happy to be here today to talk about this data management platform we've built using a combination of AWS native services as well as Starburst as the backbone for it all. To set the context though on who we are as a company and the motivation for building this data management platform with Starburst, Resilience is a biomanufacturing company based in San Diego that focuses on providing the rapid stand-up of process design and manufacturing capabilities using something called the Foundry model to essentially help other biopharmas, our customers, achieve their goals of bringing their therapeutics to market faster. And Foundry model is something that I personally believe has only been successfully demonstrated once in one other industry, being semiconductor. But in principle, it's based on building an integrated network with these highly efficient tech transfer processes that allow parts of the business to build towards these incredibly complex technical goals, but doing so starting with the design plans that clients create. So to stick some names to it and provide some examples you might recognize, albeit in different industry, TSMC is the name of one of the most successful semiconductor companies, and their clients are the tech giants even before they got giant. So think places like Apple, Qualcomm, NVIDIA, basically all these companies that leverage microprocessors to develop their own products, but who do not actually make their own chips in-house. And instead, the way this model works is that they, being the clients, will come up with the design specifications and requirements for the hardware they want. And they'll then partner with TSMC and hand over those designs so that TSMC can figure out how to build it on a pilot plant, how to scale that to manufacturing, and then how to produce it for those companies to actually incorporate in the products that they then bring to market. And the obvious question that is why, right? Why would these tech companies include a third party for all these steps? And it's basically two answers. One's faster R&D. Essentially, without having to deal with the tech transfer process yourself, it frees up incredible amounts of time and resourcing to focus just on the design. And then two, it allows for companies to have what's called an asset-light model, basically meaning that you don't have to own a manufacturing plant just to sit at the table and get off the ground with a product. So what it really allows for is for larger companies to focus on their differentiating tech, while also enabling a lot of the smaller to medium-sized companies that have a great idea, but maybe don't quite have the bankroll to get it off the ground. And back to resilience, the principle is the same, because resilience really is the first biomanufacturing foundry model company that focuses on producing products that enable other biopharmas centered around 5 areas. That's this: biologics, vaccines, nucleic acid, gene therapy, cell therapy, so that they can focus on what they're good at, while resilience will handle the analytical development, the QC testing, and the GMP manufacturing services, leveraging their designs so that they can focus on their differentiating tech, but they're basically able to do that without this enormous upfront investment in these facilities and manufacturing capabilities. Now, to make all that possible requires obviously not only incredibly talented teams, but also modern data capabilities to facilitate them internally. And that's what we're here to talk about today, because you see, resilience has existed for about 4 years. And in that time, we've raised over $2 billion in funding, grown to 11 sites, 2,000 people, a million square foot of facility space, and a digital space of over 100 applications. And while those are all numbers that we're proud to be able to state, what they really introduce is a high degree of complexity in our digital landscape. And I will call your attention to that last number, those 100 applications, because that is 100 live production apps that teams across every department need in order to do their day-to-day jobs. And data management is an area that basically every biotech company has been challenged with in the past, and resilience is no exception there. And in fact, because resilience grew so quickly, we found ourselves in a position where we had overlapping apps doing the same things. Essentially, we acquired new sites and then we retrofitted them into our manufacturing production facilities. And those sites each had their own longstanding infrastructure and applications before we got there. But we couldn't just rip out the systems and replace them entirely. And so we really needed a consistent and coherent way to reconcile all this data coming from all these sites, all these systems for reporting and analytics, while we worked to onboard them towards that resilience standard. Now, the challenge, though, is that the traditional data engineering methods for reconciling data across multiple systems all suffer from the same problem, in that they involve copying data out of the system that data originated in over to your report. You can do it as a point-to-point integration, where one data source backs one report. That is the worst. That is the least reusable, since you're going to have to set up a new connection every time. You could consolidate data across applications, which means copying from app to app to provide some sort of aggregation. Or you can take the more monolithic data warehousing approach of copying all data from all apps, all systems to one centralized place. But again, no matter which way you go here, the common denominator is always going to be the same, in that you are copying data out of the system that generated it. And the effect of that copying step, or the reason why it's so problematic, is because you're now going to have to invest pretty considerable time and resourcing into making sure those data pipelines don't break. And you're essentially going to have to live with the fact that you're always going to have things like lagging refresh rates in the data, or inconsistencies in how data gets loaded from source systems. And then on top of that, we often see that with this working model, there's no centralized way for teams to share data sets with each other. And that problem almost always extends beyond teams on the business stakeholder side, to the point that it will hinder software groups as well, since they can't properly build their informatics pipelines around these unreliable, disparate data sources. And I don't bring that up to cast a shadow on the mode of operating that teams are working in. it's really just to highlight that this antiquated way of working is way of life at a lot of biotech companies. And that's just due to a lack of tooling that's been provided to enable teams to do their best work. So this is where we started. One of our first challenges as part of building out a data management platform at Resilience was essentially to solve the operational headaches of application data management to try and beat this convention. And with that, there were a lot of requirements we were holding ourselves to, because we knew that we needed to tailor the solution to fit the needs of both the business owners and our engineering teams. So on the business side, we knew that what we built needed to serve as central control plane for data access across applications with all data available real time. The solution also needed to enable teams to be one click away from the data at all times, while allowing a good way to incorporate user-provided domain-specific logic in addition to just that raw data. We knew that what we built needed to be versatile and scale to handle an enormous variety of disparate, even unpredictable data sources going into the future. And it needed to provide the ability to easily integrate with reporting and BI tools. That's on the business side. On the engineering side, we knew that what we built also needed to serve as centrally managed control plane, but more from a tech ops perspective, such that we needed to be able to provide new connections to new data sources on the fly very easily without ever having to go into the applications themselves and do any configuration. We knew that what we built needed to serve as a good solution to scale across dozens of data sources with a mix of on-prem, self-hosted, and cloud, and fully SaaS. And we really wanted what we created to be deployable via infrastructure as code. And then lastly, we really wanted to retain that fine-grained access control so that we could provide users access to data globally, by site, by team, individual row of data, even anywhere from these very broad scope to very specific user controls. And that is where Starburst comes into play. So for those of you that aren't as familiar with inner workings of Starburst, Starburst is Enterprise Trino, and Trino is the name of a SQL query engine tool that is intentionally centered around trying to avoid the materialization of tables. And instead, it's based on leveraging federated queries across multiple data sources to try and prevent the need to build ETL pipelines to copy data into any one place. The way that happens is that you provide Starburst with connection information on the data sources you want it to hit, which are themselves databases, data lakes, data warehouses. And that connection string information on host, port, DB name, user password gets stashed in a Hive metastore as a simple properties file, and then used live at query time through standard ODBC connection to read from the underlying systems. So that when a query comes in, it gets interpreted by a coordinator instance hosted in AWS, and then chunked into its constituent parts by evaluating the from clause in the SQL statement against that metastore to essentially determine where's my query going. And then each subquery gets passed down to a tier of worker nodes, also EC2 instances, to go and transact with the source systems themselves. Then results go back up the pyramid, and joins are consolidated in memory by the coordinator before presenting results through a BI or analytics tool, which for us is Tableau. And this is a major advantage over the methods mentioned in the previous slide, because it means that one, that query is treated at a higher level than traditional joins just across schemas or tables, so that you can join across entire databases or entire systems. And you get to do that without ever having had to deal with setting up those brittle data pipelines just to copy data out of every app and centralize it so you can make sense of it. Instead, it's a live query that gets issued to every system simultaneously, and then you aggregate the data in a consistent format that you want to use. And then second major advantage here is that this approach means you can focus on establishing these connections just one time with each data source. And from then on, you can really focus on spending time and effort on new reports, new insights, which is order of magnitude increase in terms of reproducibility, in that you get to just set up the connection once and then you reuse it again and again and again for any report or integration you need. And this is where the anecdotal story about adoption of Starburst at Resilience becomes interesting, because we actually only ever intended for this to be used within research science. I myself am technically part of R&D, and that is alluded to by the names of the data sources here with LabDB, SCADA, and ELN, where originally we had the goal of just being able to join discrete results coming from instruments in a lab during an experiment with time series monitoring data in a SCADA, along with ELN, or electronic lab notebook information, basically annotations from scientists. And we were able to do that so well, in fact, that shortly after we were asked to expand the scope of Starburst use within the company past R&D to more areas like finance, purchasing, time tracking, HR, security even. It was over 11 new critical systems within the company that we added in the span of just 4 months with a small data engineering team. And the only reason that was even possible is because it didn't require us to go through the normal intensive process of loading all data from all systems and constantly having to worry about that upkeep or transfer of data. So to us, this was day and night, just amazing capability that we didn't have before, in that now, as long as you can write the SQL for it, you can connect to any key data source within the company for analytics. But if you think about it, all that was really just the setup for the next question, which is, what if you don't know SQL? Or what if the nature of the question you're asking sort of leads you to different interpretations of the data than your peers? So that's where the other area that was mentioned earlier comes into play, being data products within Starburst. On the technical side, a data product is simply a view. So it's a view that exists within the same Hive metastore from earlier, but it allows me to provide that non-materialized join across multiple systems so that I can recast fields on the fly and basically help build consistency across systems before presenting out my results. So in this example, this is stepping away from science, this is time tracking data. But what I can start to do across all these systems is select similar but differently formatted, differently named fields as part of a CTE, and then perform any calculated rollups and consolidate the presentation of data before returning results to my user. And this is incredibly powerful because now I can essentially work with business owners to codify an accurate representation of the data without having to pack all that logic into some manual report, which means that it becomes this well-defined, easy to follow table that users can preview. And that can even start to create the basis of a service catalog for requesting access to data. That's what you're seeing here in the top right. So this is a screenshot of our actual Starburst environment where we have these clickable cards that immediately give you previews to all data sets that have been certified and approved by the business owners, anywhere from R&D to commercial to finance, so that they can essentially sign off and confirm that this is the accurate representation of the data without other users having to reinvent the wheel and experience the same pitfalls of ironing out all that logic themselves. Now, to stick some numbers to it, what this means is that in the span of just a few months, we've been able to create this global system for reporting and analytics with over 20 data products that are essentially solely responsible for driving a 10x increase in viewership of BI reports across Resilience. And at this point, those data products span over 15 apps, which are themselves a mix of Postgres, Microsoft S3, Oracle data sources that are scattered between on-prem and the cloud SaaS. And then to touch on the infrastructure as code piece one more time, because we have these reusable code snippets to create new connections with new data sources, onboarding more databases is quick for our team, to the point that we're actually able to add a data source oftentimes within the same day of the request. And it is really difficult to overstate the importance of that, because it means that now we're able to get the same results that would take weeks to extract from all these systems over to our users in one query or a self-service data product. So for all those reasons, it was a very intentional choice in partnering with Starburst, because it means that we can continue to operate using the applications and data sources we need, but we can do so while providing this consistent interface for reporting and analytics through any BI tool we need. I'm going to stop there because I do want to open it up for questions, and I want to leave room for Vishal and Anthony to chime in. But before I do, I would be remiss if I didn't leave this on the last slide, just highlighting the contributions of all the key team members. So I will pause there.
Any last comments?
No, thank you, everyone. Thank you for hosting. Pleasure co-presenting with you guys, Anthony and Vishal.
Same,
Thank
Adam.
you.
Thank you, Anthony. Thank you, Adam. Thank you, everyone.
Cheers, guys.
Yes, bye.